Right, so today we're going to be looking at exponents. And when we talk about exponents, it's actually the little number that's up in the corner of a power. And a power is the entire expression. So let's say I have a fraction like 1/2 to the 5th power. And this whole thing is called a power. Okay, and this number in the corner alone is called your exponent. And the number that is being multiplied repeatedly is called the base. Okay, so what this means is that you have 1/2 multiplied by 1/2 multiplied by 1/2 times 1/2 times 1/2 because of this exponent 5. So that's telling me that I'm going to have 1/2 times 1/2 times 1/2 5 times. So it's repeated multiplication. Okay, so an exponent is the superscript number up in the corner that tells you how many times you're going to be multiplying that base number. Okay, so there's two numbers. One of them that's being repeatedly multiplied, and the other number tells you how many times you're going to be multiplying it. Okay, so let's give you an example. I want to make sure we understand the ways in which we can write these things. So I'm going to give you a problem, and you're going to write it in exponential form. Say I have -7 times -7 times -7. And then b is going to be, let's say it's pi times r times r times r. So looking at a, we have a number repeatedly multiplied. And the number that's repeatedly multiplied is -7. So since -7 is repeatedly multiplied, that is called my base. Okay, the number that is repeated is called the base. So my base is going to be -7. Now I need to make sure it's got parentheses. The parentheses means I want the negative and the 7 to be multiplied itself 3 times. Okay, so that's the way we would rewrite that problem using exponents. Now the next one, we have pi times r times r times r. Now if you remember, a base is the number that's repeatedly multiplied. So what does it mean when we have pi is being repeated twice and r is being repeated 3 times? So that means we're going to have 2 different bases, and that's okay. So we're going to have pi, and we're going to have r. Okay, now the base would be pi. How many times am I multiplying pi? I'm multiplying it twice, so it's pi to the 2nd power. And now I have another base of r, and I'm telling, well, I can see that it's being multiplied by itself 3 times. Okay, so in this case, we have 2 bases, and that's okay. And we're just letting you know that this base is multiplied twice. This base r is multiplied 3 times. You don't need the multiplication in mathematics. Anytime you have a number next to another number or another term or another expression, it means multiplication. So this would be the exponential form of those given expressions. All right, so let's look at example 2. And it's telling us to calculate the value. So we have 2 examples. One of them is -2 to the 4th power. The second one is -2 to the 4th power. So they look similar, but one of them has a set of parentheses and the other does not. Now, what is the difference? Well, parentheses have the purpose of grouping things together. So the parentheses are telling us that the negative and the 2 are being raised to the 4th power, which means my base is -2. So that's the number, -2, that's going to get multiplied by itself 4 times. Okay? Now, I'm going to do the other example simultaneously at the same time so you can see the difference. This means the power of 4 applies to the 2. There's no parentheses, it's grouping the negative with the 2. Okay? So this just means 2 to the 4th power and then the negative. Now remember, order of operations always says parentheses first, then your exponents, then your multiplication, division, and then your addition and subtraction, or PEMDAS, or what I like to call it as GEMDAS for grouping symbols. So if we were to follow order of operations, you would have to do parentheses first. Okay, so that's -2 in there. And then after the parentheses, you do the exponents. So that means -2 is being raised to the 4th power. But when you do order of operations over here, your order of operations says parentheses first. Well, there isn't any parentheses. Then the next step would be exponents. Okay, 2 to the 4th. Okay, and then done with the exponents, multiplication or division. This negative, you can think of it as an invisible -1 times 2, or just stick that negative on there and think of it as a subtraction. But either way, this negative is not part of the exponential property. So we still figure this out as 4, makes that negative, bring it down, and 4, which makes this -16. Because that negative did not carry through to all of the 2's. However, over here, you will have negative times a negative is positive, so that's 4. Negative times a negative is another positive, so that's 4. And over here you get 16, positive. So you see the difference in having the parentheses and not having the parentheses? So the parentheses are what's telling you what is being raised to the 4th power. Here, it's the 2 to the 4th power. We're not grouping the negative with the 2, we're just tagging that negative along to the very end. It tags along on the final answer. Okay? And another example. What about when you are trying to evaluate an expression that's got all of these powers in it? Example 3. So let's see. So calculate the value of A, and another example B. A says 3 plus 2 times 3 to the 4th power. And example B says 3 to the 3rd power minus 8 to the 2nd power divided by 2. Now we are going to need order of operations. So let me write that down. A little darker. Okay. G stands for grouping symbols. It used to be P for parentheses, but as we go on in algebra, we realize that we have other grouping symbols besides parentheses. So are there any grouping symbols? No. Next, we're on exponents. This is my exponent here. And that's going to be 9 times 9 makes that 81. Okay, so it's not 3 to the 4th is not 12. It's not 3 plus 3 plus 3 plus 3, that would be 12. But repeated multiplication gives me 81. And so now I still have this times 2. I still have the plus 3. So now I'm done with exponents. Multiplication is next, so I'm going to do these next. 1 times 2 is 2, 8 times 2 is 16. Okay, so I'm done with my multiplication. Next is my addition, and together I get 165. So as long as you go in order, you should be good. Next one. There is no grouping symbols, there's no parentheses. And exponents are next, so we'll do this one next. That's got to be done first. Then this is another exponent that has to be done first. and then we'll divide it by 2. So what is 3 times 3? That's 9. And that 9 times another 3 makes 27. And 8 times 8 is 64 divided by 2. Now, we usually tend to want to go left to right, but you need to pay attention to the order in which we're doing these problems. There is no multiplication next. Now I'm on division. I have a division right here. 64 divided by 2 is 32. Now I don't have any addition. Now I move on to subtraction. I can add the opposite. So what is 27 plus negative 32? And that becomes more negatives left over, so it's 5 of them left over. Okay.